Okay, so again, what we have here is we have my right triangle machine. It's set up showing basically the very first right triangle that it's capable of making here, which starts at 89.97 degrees on this side. It's so small you can't even see it. It's so small that the measure of the leg going up is coming out as 0. Now we know it's not truly 0, but the scale here is so small you can't even see it. And it's also so small that it's showing that this hypotenuse, this is the measure of the hypotenuse here, it's saying it's equal to the measure of the leg, and that there is no other leg. But actually there is a very small 0.03 degree angle here and a 89.97 degree angle there. Almost a right angle. If you add those together, you'll notice that they add up to 90, which is going to be really a big deal right now as we go through this for a little bit. But what I'm going to do is I'm going to go ahead and I'm going to animate, let it run, and we're going to capture some values in this spreadsheet. So let's go ahead and turn the animation on, and we'll look at those values at least for a bit. When it gets off, I'm going to turn it off here. Capturing a lot of values there. There we go. And from here on down, we'll just delete those rows. Okay, so we got all the way until there was 89.68 degrees here. And apparently that was too small for it to capture any more lengths than this. It reached basically 0 and could not process anymore. So, but these are the angles here, okay? So again, this is, I'm gonna turn all of this recordings off for just a moment because I want you to really focus with me, and I want to be able to, have a C, and well, let me just help you understand here. So A, or alpha, lowercase a right here, it looks like, and it's alpha. That is the measure of this angle that we had on the left, right, of our right triangle as it swept from left to right. And beta, this looks like capital B, that was the measure of this angle on the right as it moved from left to right on our screen. B1 is the segment, the leg that's on this side of the right triangle, and B2, or A1 rather, was the leg on this side of the right triangle. And then our hypotenuse measured 6.88. Okay, that was our hypotenuse, and I'm going to put it right there, and I'll just bring that all the way down here for all these measures here. So we can basically just see, you know, the hypotenuse listed as well. So we're gonna do our trig function calculations. So how do we do sine? Well, if we have to do sine of alpha, or this angle on the left, so I'll just call it sine of A, right? It's angle A, is the big capital A is going to be over here, and I'm going to put here cosine of B, and we're going to compare A and B. Now the reason for that is because you have to write an essay now about the relationship between sine and cosine, okay? Sine and cosine of these angles. Okay, so, and that's because these angles are complementary. Now, we'll turn this back on for a minute. And, oops, no, I don't want to record that. Let's remove that there. Okay, we will. I guess finish our function here. So the sine of this angle is equal to the opposite side. So from A, it's this leg here. And we already said this leg here is equal to A1 divided by the hypotenuse, which we said was E. So we're going to put that function in here. We're going to say it is equal to A1 divided by E. And we'll put that in. And it believes that that is 1 at that point. So here is our calculations of all these sines of A, or alpha, or angle A. Sine of angle A. We'll just go down to there. That's good enough. Okay? And you can see it's at 1. It actually wouldn't quite be 1. These are rounded. but it approaches 1 and then it gradually goes down from 1. Now let's measure the cosine of angle B. So the cosine of angle B, let's think about this. What would that be? Well, cosine is adjacent over hypotenuse. The adjacent side is this side over here, and we're going to put that over the hypotenuse. So let's insert our function. So we're going to insert our function here. Here's my input. Oops, my function input in here. We will say this is equal to. All right, now this angle on the right side, this leg on the right side is the one that's adjacent to angle B. So this leg over here on the right side is the one I need to measure for cosine. So it's going to be equal to this divided by, that's going to be the hypotenuse, adjacent over hypotenuse. We're going to enter 1. Holy cow. Let's bring that formula down. What do you notice? For every single triangle that this device was able to record, let's find the difference. Let's put another formula in here. This will be the difference between the sine of A and the cosine of A. So we're going to say this value here will be equal to the difference between this one and that one. So we'll take sine of A and we'll subtract cosine of A, and we find that there is 0 difference. And as I bring this down, you can see, guess what? There is 0 difference regardless of the angle. There is no difference between the sine of one angle and the cosine of another angle, regardless of those angles, if those two are complementary. Well, were these all complementary? We better confirm that. So we're going to find out, are they complementary? And I'll put the function together up here. We'll say, how would we know if they're complementary? Well, complementary means that their angle measures equal 90. So if we take this plus this, we add together their angle measures, we're getting 90 degrees, and as we scroll it down, no surprise here, not trying to really waste your time, but I want you to know 100% certainty here, you understand what we're talking about. As long as we're talking about a pair of complementary angles, they are going to have no difference between the sine and the cosine, no matter what pair of complementary angles they are. If it's 22.92 and 67.08, still their sine and cosine are the exact same number. So why would that be? Okay, let's go ahead and turn the animation back on, and we'll just get our little guy here back, and we'll turn the animation back off. Why would that be? Let's go back up here. Why is it that there's no difference between the sine of this angle and the cosine of that angle? Well, the reason is, pay attention to when we talk about what our formulas are. This over here, this angle, the sine of this angle, sine says opposite over hypotenuse. So we're talking about the length of this triangle over, or this side, or this leg, over the length of our hypotenuse. And cosine is saying, give me the adjacent of the hypotenuse. So we're talking about the exact ratio. It's the same exact ratio because we're using this leg as the adjacent for, it's the same leg, which is the adjacent for B, is the opposite for A. So it's the same exact formula. Okay? It's the same exact formula. Now, you have to mention this inside of the scheme of the triangle, the right triangle. That's where this comes from. But the reality is that we can measure sine and cosine for any angle less than 90 degrees, right? Any angle less than 90 degrees, you can measure it. And maybe in Algebra 2, you'll learn more about, you know, other situations where maybe it goes past 90 degrees and you could still learn how to do it. But for now, anything that fits inside is 90 degrees. Well, why? Let's talk about why is this always equal to 90? Because the interior angles of the triangle are, they sum to 180. That's the triangle sum theorem. The sum of the measures of the interior angles of a triangle is always 180. And in a right triangle, this one's always 90, which leaves 90 degrees to be split between these two. So that's the reason that these two are always complementary. Now if I draw, let's say I draw any other angle, okay? And if I draw that other angle, what's going to happen? I'm going to go ahead and close this spreadsheet for a minute. And let's just draw a couple of rays to form an angle. Okay? And we'll go ahead and measure that angle. And I'm making it acute on purpose. So we have an angle here, and it's 47.86 degrees. So now I'm going to draw another angle, but this, actually I'm going to measure an angle with a given size. Let's see if I remember how to do this right. So what do I want the size to be? I want it to be the complement of 47.86. So 90 minus 47.86 would be 42.14 degrees. Okay, so we'll say okay. And now I can draw those rays there. And I've drawn a complement right there. Complementary angles, a pair of complementary angles. Now, these are a pair of complementary angles that could theoretically be a pair that exists inside of a right triangle. In this case, they do not. They're not inside of a right triangle. Okay? So, they're just angles that exist. So this is what's important to note. We do not require that any angles be inside of a right triangle in order to get their sine and cosine. That's not a requirement. Okay, we can just use the ratios that we know exist and then apply it to any triangle that's not inside. So here we go, turn our lamp on, and we're going to just verify. Here we go. The first angle is 47.86, so if I say, what is my trig function sine of a 47.86 degree angle? Uh-oh, Mr. T has a problem. There should be no negative signs here. You know what the problem is? This is a really good opportunity to learn something about your calculator. There are measurements. There are measurements for angles that are not degrees, okay? It could be measured in radians or, you know, something like that. So we're going to go in here and make sure that we have our document settings here, not to measure angles in radians, but we're going to change it to measure it in degrees. And we'll go ahead and change that. So now that we've changed that so we're for sure measuring in degrees, my sine is 0.741508. And then my cosine, so I've got trig, cosine of the other angle, which was 42.14 degrees. And you can see we've validated it. What if we went the other way around? What is the sine of a 42.14 degree triangle? And what is the cosine of a 47.86 degree triangle? And you can see that they're the same. Okay? So this is what you're going to want to write about. When you're in your essay, don't only talk about triangles. Okay? You've got to explain that it's for any two complementary angles, regardless. Okay? They don't have to be part of the same right triangle in any way. But you want to make sure you're clear that the ratio that exists for a 47.86, which for the sine of this is equal to the ratio for the cosine, the cosine function for the other angle. So these two angles, now you can think about why they might complement each other if they come to 90 degrees. Complement, go well together, right? How they fit together. Think about that, how they complement one another within this angle. They come to with this triangle, they come to 90 degrees. Outside, they still have something very important, which is the relationship between the sine of one and the cosine of the other. Okay, get writing on your essay. You can use paper or you can type it up and you can make some graphics like this if you want. It'll help you.